Okay, here we have some derivative stuff with this notation. They give us a function and they give us some numbers in the table here. When it gives me f of x and says find the slope of the line tangent of f at x equals pi, that's just your derivative and then plug in pi for that guy, right? So when you do the derivative of cosine, you're gonna get negative sine of the angle, leave the angle alone, times it by the derivative of the angle. When you have the derivative e to a power, you go e to that power, times it by the derivative of that power. The derivative sign is gonna be cosine. And now we're supposed to plug in the pi. So sine of 2 pi is 0. So that part goes away. And then cosine of pi is -1. Sine of pi is 0. So e to the 0 is 1. So 0 minus 1 gives you -1 for that part A. For letter B, it gives us this. Now, what I want us to kind of study here, and this is why my of us practice multiple choice, you see some more of those on there, but you're on the backside in your blue packet on the backside of your second sheet, you have all of your notation problems. You have your product or your quotient or your chain rule. And the way you do your chain rule, if you have a composition function, you do the derivative of the outside function, leave the inside function alone, and then you times it by the derivative of your inside function right there. So check that blue sheet for all those notation type problems. But when I saw that, that's the chain rule, that's a composition function there. So when I do the derivative, I got to do the derivative of the outside function, leave the inside function alone, and then I times it by the derivative of that inside function right there. And now we're supposed to plug in the pi. So I do h prime of f of pi times f prime of pi. When I do f of pi, I don't know what that is. I got to take the pi, plug it in for those x's right there. So I'll get the cosine of 2 pi plus e sine of pi. Sine of pi was 0, e to the 0 is 1, cosine of 2 pi is 1, so 1 plus 1 gives me 2 right there. So I have h prime of 2 right there, and in the f prime of pi from letter A, we figured out that that was -1. So this is -1 times that h prime of 2. Now when you do h prime of 2, that's your slope of your h function at 2. They don't give us a table of values for the h and h prime, but they give us a graph. So if it says h of 2, I look at what is that y value, but h prime of 2, I got to find the slope of that curve at 2. So when I go to x equals 2, that is a line. So I just write down 2 points on it. I chose 0, 0, and 3, -1, wrote down those 2 points, found my slope, got -1/3, but then that negative was out there, so that turned into a +1/3. But if we practice those, we could be really good at those problems. Same thing on letter C. Letter C gives me something times something. So I'm going to use my product rule here to take its derivative. So I'm going to do first function, write it down, times it by the derivative of the second, plus the second function, write it down, times it by the derivative of the first. Now, when you do the derivative of g of -2x, to do the derivative of g, you're going to get g prime, but you always have the times it by the derivative of the inside. That's why I times that by a -2. So it was a plus with your product rule, but you times it by the derivative of -2, it became a -2. And now we're going to take this 2 and plug it in. And make sure you show that because you could get some credit if you do that derivative correctly there, okay? So take the 2, plug it in for all these x's. That becomes a 4, 2, 2, 4, -4. And then g of 4 and g prime of -4, they give us those numbers from our chart. I got my g column and my g prime column, so that's where I'm getting the 5 and the -1 from, is from that chart. H prime of 2 is what we calculated over here when we did the slope. That slope was a -1/3, so I can use that again. And then h of 2 means that when on my h function, when my x is equal to 2, what is my y value? So when my x is equal to 2, I'm like, man, I don't know what that y value is. It could be -0.75. It could be -2/3. I don't really know. So you got to find the equation of this line real quick. So I did 0, 0, and 3, -1. Actually, I knew the point was 0, 0, and we already knew the slope of that line segment was -1/3. So if you use a y equals mx plus b, you can get y equals -1/3 x, the equation of your line. And then when you plug in 2 for the x, because that's what you're trying to do, is figure out when x equals 2, what the y value is, you are going to get a -2/3 right there. So you can't assume, you know, when you look at that, it doesn't look like it's 1/2. So you got to do something to figure out what that is. Just find the equation line, do your algebra 1, so get your -2/3, and then make sure that works in your brain, do your basic arithmetic, get that answer as -3 right there. Last part of that, it says, is there a number such that the derivative is equal to this? This is your mean value theorem. When you see language like that, and it must be true, that's theorem talk. And the reason I know it's a mean value theorem is because I see the derivative is equal to a number. Watch the theorem video, at the beginning there if you need a little refresher. But if I see the y value is equal to something in between two other y values, that's intermediate value theorem. If I see some y must have derivative equal to 0, I write down Rolle's. If I see the derivative is equal to a number, I write down mean value theorem. Okay, so at least just write down MVT. If you know the gist of those, you're going to write down MVT. Now, it tells us G is differentiable, which means it's automatically continuous. And we kind of see right here, this is continuous. We don't care about the H anyways there. It just says G is differentiable, which means it's automatically continuous. And that's all it's asking about is this G prime. Now, normally when I want to say the derivative is equal to -4, I got to take a slope because your mean value theorem says your derivative is equal to this f of b minus f of a over b minus a. So if I can show that a slope is equal to a -4, then that means the derivative is going to be equal to -4 because it tells me differentiable. So I just jot down G is continuous and differentiable, and I'm just going to try and find a slope. Now, usually I will choose like x equals -5 and x is 0. A lot of times I'll choose the endpoints there and I'll write down -5, 10, and 0, 0, and I'll do the slope right there. But when I did that slope right there, it did not give me the -4. So I just had to kind of backtrack. And I finally found one. If I wrote down -5, 10, and -3, 2, and I did those two slopes, and I did that one slope of between those 2 points, subtract the y's on the top, x on the bottom, I did get a slope of a -4 right there. So that's the average rate of change. That's your f of b minus f of a over b minus a formula. So if your average rate of change is equal to a -4 and you have a continuous differentiable graph, that means your derivative also must be equal to that -4. So just jot down the big things there. Jot down continuous and differentiable when it's theorem talk. Jot down the mean value theorem. You're going to know the gist of those things, and then we'll be good there. Volleyball.